Good morning, everyone. If you're just tuning in, this is Andrew McDonald and Dan Lance from the PAC Global team. We're just going to give everyone a minute or so to log in. Lots of people joining us right now. So we'll just wait another minute or two and then we'll get started. Good morning. If you're just joining us now, great to have you with us and the PAC Global team. We're just going to wait one more minute for folks to join in, and then we're going to get right into our session. Okay, well, listen, Remembrance Day greetings from the PAC Global team. My name is Andrew McDonald. I'm the project manager for PAC Next, which is PAC Global's program of sustainability and circularity initiatives. Before we get started, just a quick note on PAC Global. PAC Global is a nonprofit organization that provides a safe place for packaging leaders from across the packaging value chain to do all kinds of things, to innovate, to educate, to collaborate, certainly, and even to celebrate. And so we welcome you here today for a specific session on the Consumer Goods Forum Golden Design Rules. And without further ado, I'm going to turn it over to my colleague, PAC Next Director, Dan Lance, to get right into the heart of our program. So welcome again, everyone, and over to you, Dan.
Good morning, everyone. Happy Remembrance Day to everyone, and thank you very much. We have 90 minutes this morning. It's a lot of content for 90 minutes. I'm going to be going quite quickly, simply because there are 9 golden design rules, and so it takes a while just to get through all of the content. If you have any questions, please share them in the chat box. We will be taking a small pause after golden design rule number 5 to answer some questions, time allowing. Otherwise, what we'll do is we'll table all your questions and we'll make sure to get back to you after the session today. So let's just get started. So, introduction. Consumers are looking for more sustainable packaging. Today, believe it or not, 65% or about 2/3 of the public are now looking for packaging that's recyclable or packaging that's reusable. Believe it or not, about 5 years ago, when that same survey was done, recycling was barely even on the list at all of something that consumers were looking for in their packaging. Yes, it was a nice thing to have, but other things were more important. So things have really shifted. We can thank social media, ocean plastics, pictures of birds and whales and tortoises and everything else and turtles. So that's really got everybody now thinking about packaging, and more specifically, plastic packaging. And of course, the golden design rules are strictly associated with plastic packaging, which will be our focus today. Importantly, for you as consumer goods manufacturers and others, retailers, not moving to sustainable packaging today is now going to cost sales. So the golden design rules were developed within the New Plastics Economy. It wasn't part of the Ellen MacArthur Foundation program, rather it was part of the Consumer Goods Forum's program, but it all is bound within the New Plastics Economy. So when you look at the new plastics economy, you have the idea is that once the material is in the economy, so plastic packaging is in the economy, it needs to stay in the economy forever, or as long as possible at least. So it looks like a racetrack. I call it like a horse racetrack. And you can see on the inner circle, the inner track, the training track is reuse. So once the material's in, if it's got a reuse opportunity, reuse the material, keep it going around and around and around. Even after reuse a number of times, packaging eventually needs to be replaced, but it should still be recyclable. When the material is in, even if it's not a reusable package, think a single-use water bottle, for example, the idea is that the package should go around and be recycled as many times as possible. Plastic packaging can go around about 7 times mechanically before it starts to break down. But the idea is to keep it in the economy, the circular economy, as long as possible. So go around and around and around. Ideally, with the new plastics economy, the bottle should go back into another bottle. The fun part about all of this is that about half of the plastics in North America are going to textiles. So you can imagine the joy of people trying to get enough material right now to fulfill recycled content requirements. And we'll talk about that a little more later. So just as a background, if you look at it, in Canada, these are recycling rates. These are actual posted recycling rates for Manitoba, Ontario, and Quebec. The Canadian rate is just the prorated against the population for each of those provinces times their recycling rate. So the big goal for plastic packaging under the Canada Plastics Pact is 50% recycled rate and 30% recycled content. But the 50% recycled rate is the benchmark that everybody's looking for plastic packaging. So you can see in Canada, I think this is a surprise to some people, but we're doing quite well on things like PET bottles. That's the number one bottle. Think the water bottle, for example. Thermoform, so think your produce aisle where you buy your spinach or lettuce or something, and it's in a tub, clear tub, and there's a lid on it, for example. They're over 50% already. All plastic deposit containers, so that's beverage containers, even with Ontario's rate being lower because Ontario doesn't have deposit, is still the highest at 68.5%. We've got HDP bottles and jugs, that's number 2. So think of natural jugs would be things like milk cartons, for those of you outside of Ontario where we use bags in Ontario, but outside of Ontario, West Coast particularly, they use HDP natural milk jugs. Other HDP products include things like detergents. So your laundry detergent, your dish soap, and things like that are made out of HDP bottles. And so they're doing very well as well. Now, the other ones that I've got the red square around are below or very much below, but there's not all bad news in that. Some of them are quite close, HDP tubs and lids. So think of like ice cream tubs, for example, LDP lids. That's the lid that's on the HDP tub a lot of the time. And polypropylene, number 5 plastic, those are smaller tubs. They can be small squeeze bottles, things like that. They're around 40%. So they don't have far to go. The thing is with the goal of 50% recycling rate for all plastics, it's for all plastic, not just the ones that are doing really well. So we've got some others that are doing not nearly as well, including plastic films. So it's shopping bags, bread bags, dry cleaning bags, things like that. Multi-laminated plastic pouches. So think about all those stand-up pouches you now see in your grocery store or your retail outlet. Expanded polystyrene, so that's cushion packaging, the little beads that they form together into shapes, that's expanded polystyrene. Non-expanded polystyrene is rigid. So most common example you could think of is the snap-off yogurt cups. Those are made out of polystyrene. And degradable plastics, so something like PLA. Polylactic acid is a number 7 plastic. All other plastics as well. So those are typically combination plastics or others. So other things that are plastic, not the typical number 1, 2, 3, 4, 5, 6, or 7, or 5 or 6. So they're not doing nearly as well. Now, the other plastics in PVC are at 0, only because right now they really don't get recycled. When you look up the reports, you'll see there's some recycling, but really they're not technically being recycled. So there are 9 golden design rules. I'm not going to speak long to this page because I do get into each of the 9 of them in the course of the next hour and a half. But the big thing to notice is half of the golden design rules are associated with flexibles. And it makes sense because as much as the flexibles are an increasing proportion of the recycling, or sorry, of the plastic stream, more and more so. You're seeing more and more plastic film, particularly pouches, but they're also low in recycling rates. So the idea is to do what is possible to get recycling capabilities up for that resin type and format, both the resin and the format. So polypropylene and polyethylene are used for films, but the formats can be just a bag or it can be a pouch, for example. So you can see a lot of golden design rules are assigned to that. PET bottles are one golden design rule. That's about 17%, about 1 in 6. The 20% is the HDP and polypropylene rigids. It's addressed by 2 golden design rules. And then we have the smaller ones. They call them problematic elements. It isn't so much that they're problematic, it's just that they're not at scale, more difficult to manage. And as such, they will be addressed in one of the golden design rules, number 2. And then the PET trays, which is the other part of the PET stream, number 1 plastics is golden design rule number 5. So why the golden design rules for Canada? The golden design rules create consistency, allowing economies of scale to be achieved at the recycling point. It's important because recycling is expensive. It's not money making like a lot of people believe it is. So the idea is if you have fewer materials, you'll have greater economies of scale, which will provide opportunities for more investment. If you're moving plastic packaging from non-recyclable to or not recycled, like number 7 plastics or PVC plastic, for example, and you make them, you move those containers into recycled plastics, you're now going to have better yields for, pardon me, the mixed plastics that go to end markets. For example, we ship commonly a mixed plastic bale of 3, 4, 5, 6, and 7 to an end market. They have very low yields. The idea is if we can move to more recyclable plastics, then we're going to have higher yields for the end markets, which will bring their cost down, which means the cost for recycled plastic will be lower, which means your cost to put your recycled content into your containers will be lower. So there's lots of reasons, economic reasons to bring it in, and the golden design rules for Canada to increase the opportunity for recycling. The other thing, of course, is if the end markets know that they're only going to be dealing with a certain number of plastics, specifically PET number 1, HDP number 2, LDPE number 4. LDP is commonly in the film, and number 5 is polypropylene. Then you're going to say, oh, great, I know I can go here in Canada. I know I'm going to have a much larger source of only the materials I really want to have made available to me. And as such, then I will make greater investments. So, golden design rule number 1 applies to PET bottles. PET bottles should be transparent and clear, uncolored. So there's a lot of PET in the marketplace that's colored, but colored clear, such as a 7-Up bottle, is light green. It can be light green or light blue. Clearly Canadian containers are light blue. That's fine. But when you get into the opaque PET containers, the ones you can't see through, and there's a number of them out there in the marketplace. I don't want to point any fingers. 1 second, folks. I don't want to point any fingers, but there's a number of PET containers in the marketplace that are opaque and colored. They really don't get recycled. So they want to see everything move to transparent and clear because that's got the greatest opportunity for recycling and kept in the circular economy. It's got the clear PET's got the highest demand. Think about Coke, water bottles. Coke wants a bottle to bottle. Water bottles are commonly in recycled content material. It has the highest potential recycled content application. So the idea is that if all the PET is clear, then it has the opportunity to go back into the most PET bottles. So getting the color out, only maintaining just clear PET, more PET yield at the end market, lower costs, more PET available for recycled content. Opaque PET is not recyclable into anything other than other opaque PET. When you think about it, you take all those colors, the PET color can't come out in the mechanical recycling process. And as such, you generally get a black. If there's enough to even have an economy of scale available that warrants taking all of the colored PET bottles and and then separating them out from the clear before the PET clear is recycled, and then making something else out of it. The other thing, this is PETG, which is glycol modified PET, is not compatible with PET. Now, PET, you can always tell a PET bottle, if you look on the bottom, other than looking for the Mobius loop, which is often hard to find, is there'll be a dot in the middle of the bottom of the bottle. Whereas PETG in the bottom, it looks like a PET bottle, but when you look at the bottom of the bottle, there'll be a line across it. So it's not a PETE in that sense. PETG is the material has got the glycol in it, makes it incompatible with PET. It is a contaminant. It does disrupt PET recycling. You often find PETG in things like orange juice. So the golden design rule number 1, application. The bottles on the left, those are just an example. There are lots of them, of course, water bottles, soft drink containers. There's all sorts of PET in the marketplace. It's the most used and most common plastic in the market. So they're all fine. But the containers on the right, so you can see they're opaque. They are PET, but all those colors, unfortunately, when it gets to an end market, you can't blend those colors into the clear, because then it would make the clear not clear. You would have all sorts of problems with it. And also the color doesn't come out in a mechanical process. Now, if we ever get to chemical recycling, there's an opportunity we could use the colored PET bottles, but chemical recycling is probably 5 to 10 years away before we get to that point where we will have something available. So the other thing with golden design rule number 1 is you want to make sure that the PET you're putting into the marketplace doesn't have anything that's going to impede the ability to recycle the material. So for example, no PVC, polyvinyl chloride, that's number 3 plastic, but you often see PVC as a label on a container, or PVDC, which is a derivative of PVC. So you don't want to see any of those on. And the reason is that PVC and PET, they really don't like each other in the mechanical recycling process. And as such, when they go through the recycling process, PVC also sinks in the sink float when they're washing the bottles. So the PVC will sink with the PET, and it'll be captured with the PET, which means it goes through the PET recycling process, and then it causes a lot of problems when they're trying to make new pellets. The PVDC, the PETG, as I mentioned a minute ago, just in the bottle, but also in the labels, same thing, and same with PLA. They all are problematic because they do cause problems for the recycling process for PET bottles. So avoid those for all labels. The shrink caps at the top, we'll get more into that when in one of the later golden design rules. It's applied to HDPE and polypropylene, but same idea is that avoid anything that's going to not be easily separable from the PET in the recycling process. Now, full body PET shrink is acceptable only if the color can be removed, such that the ink washes away completely, doesn't leave anything in suspension, and such that it would stick to the PET flake when it goes to be melted and made into new PET. Because if there's color and ink, et cetera, still there, then you can imagine you're trying to make a clear PET pellet, you're going to have blotches all over it or other issues with the recycled pellets. The label should not exceed 75% of the bottle. The reason for that is when a bottle goes through a recycling facility, it uses an optical sorter, which is near infrared and visible spectrum of light, which is used, it shines down on the bottle from a machine, and then about a few inches later, then an air jet is there, a bar with holes in it, and it shoots the bottles up and out of the stream. If the label is greater than 75% of the bottle, particularly where the label is not the same resin as the bottle, then of course the optical sorter is going to see a different resin. So if you were to put a full PVC bottle label on a PET bottle, as bad as the PVC is by itself, the machine also won't find the PET bottle, and as such it will miss it, which means we lose capture of the PET bottles from the recycling system. We don't want to do that. So if the bottle label is limited to 75%, and generally speaking, if there's an inch at the bottom, an inch at the top, 2.5 centimeters at the top and bottom of the bottle, with the use of the optical sorter, it will find the bottle and it will eject it into the proper stream. So the idea, keep the label smaller even smaller than that is better, but keep the label small enough that the optical sorting system can see the root bottle, in other words, a bottle underneath, and see that resin and not the resin of the label. Ideally, the label will be what's called polyolefin based. Polyolefins are HDPE, number 2 plastic, LDPE, number 4 plastic, or polypropylene, number 5 plastic. And the reason they want that is that when the bottles are shredded for washing and cleaning and it's a decontamination, get the organics out, for example, the polyolefin materials will float to the surface of the water bath and they can be taken off. They can be skimmed off. So just like the caps will. Caps are typically polypropylene on your soft drink or water bottles. They will float to the surface, they will be captured, and they can be recycled. So a polyolefin-based label will float, the PET will sink, keep the two of them completely separate, and then you have a great opportunity to maximize the yield of your bale of material that goes to an end market. So you think about a PET end market that's buying water bottles, for example. Typical water bottle, the no-name brand ones or the store brand ones are about 9.2 grams or so. The cap is only 3 grams. But when you think about it, that means that the yield to the end market for PET is only 75% approximately for that bale. Well, the end market for PET wants PET. They don't want other things, but they still want to be able to capture the material so they can sell the PET to somebody else. Sell the polypropylene to somebody else, and then they can recycle that material. The other thing you can use is a paper label. As long as it's really small, don't make it really large because there's all sorts of problems with paper sticking to plastic and then it causes a problem for the recycling process. So keep the paper label small. You think about it, a typical, again, water bottle, a lot of the time the label will only be like this big. So that works really well. It can be easily removed. The other thing to bear in mind is make sure that your adhesive is water soluble or removable in a light caustic solution. Because if the adhesive stays on the bottle, the adhesive will go through the recycling process. And again, it causes problems. You'll either get marks or you'll get weak spots in the PET recyclate. A lot of problems happen with adhesive stuck to the bottles. So the adhesive needs to be removable completely in the wash cycle, such that it leaves only PET to go through the cleaning and the recycling process. The other thing is nylon barrier layers are a large problem for PET recycling. You can see a nylon barrier layer. If you look at a ketchup bottle, for example, and you hold it up to the light and you shake it back and forth, just a little bit, hold it up to the light source, you'll see there's a shine in the bottle. That shine is the nylon barrier layer that's in there. And it's in there on purpose because the tomatoes are acidic. And you often see them also in juice bottles as well. So you'll see a nylon barrier layer in there. So it helps protect it, keeps the material safe, lasts longer, increases shelf life, etc. However, nylon and PET don't get along either in the recycling process. Now, if the amount that you're using is very small, generally less than 10% of the weight, and preferably less than 5% of the weight of the bottle, they can manage it. What they do is they'll dilute it out of the process. If there's too much nylon, it causes a huge problem when it comes to extruding the new pellets because nylon burns. It melts at a much lower temperature than PET. And as such, when you're pushing it through and making new pellets of PET, the nylon burns, causing large problems trying to make a consistently high quality PET recycled pellet. So that's the end of golden design rule number 1. Golden design rule number 2. This one's a big one. This has got a lot going on in it. First off, the rule has a number of elements. The first is no undetectable carbon black. So there is an awful lot of black plastic in the marketplace, a lot. Now in PET, they're saying no opaque PET at all. So that's no black PET either. And that's no undetectable black PET. There's just no black PET. So no black at all for number 1 plastics. The undetectable carbon black, we'll get into it in a second, but that's part of it. No PVC, we mentioned it already, but now they're saying don't use it at all. Not just don't use it for labeling and that, but don't use PVC for any packaging. No expanded polystyrene or polystyrene rigid. The one thing that's accepted is no what's called XPS, extruded polystyrene, which is the meat tray. They're silent on it. Right now, they're not saying. An early version of this, when they were developing the golden design rules, it had XPS as an exclusion. Right now, they're just silent on it. The other thing, no PETG and no oxidodegradables. The undetectable black is when using current technology. There is later technology, brand new stuff for the recycling system that can capture carbon black, but right now most facilities can't. So black's as a growing problem. It doesn't just come in one material. It comes in number 1, 2, 4, 5, and 6 resin. So when it's going down the recycling line in a recycling facility, unfortunately, you can imagine a black container on a black belt. You can't really see it, and the optical sorters can't see it. Now, people can see it, but people can't understand and differentiate. It's really, really difficult to differentiate between resins, even when they're not black, but when they're black on the belt and they're dirty because recycling facilities do not get beautifully clean material. It's often contaminated. It's very difficult to tell it. So it typically is managed manually in a recycling facility, but then it gets managed as a blended plastic resin stream. So, but they don't want to stop using black altogether because black plastic is a great place to put recycled content into, because it isn't always just food contact, but there's a lot of black plastic. So it's not recognizable with today's technology. There is technology out there that can find black plastic. A couple of things. One is brand new. We can see it on the belt. Others, what they do is they let the black container fall just off the end of the belt, and then they can see it at that point, and then they can eject it then. So it is possible, but it's new technology. The technology is expensive, and it isn't typically found in today's material recovery facilities. That's what MRF is. So they're saying put something in it where you can find it. So you can use black, but put a identifier into it. So for example, there are black plastics in the marketplace that, for lack of a better word, fluoresce. It doesn't fluoresce, it's not fluorescent, but when it goes under the optical sorter sees it as blue plastic, and then it can sort it. So that's good. So make sure that if you're using black plastic, it's discoverable black plastic. The other thing is right now you can't separate by resin. So again, it goes out as a blend, which means the end market now has to deal with it. They can use sink float technologies and other things to separate the different plastics out. So they can manage the black plastic, not a problem, but it's getting it out of the MRF, from you pick up your materials at the curb, it goes to the recycling facility. It's that point that's the difficult point in the chain, which is what this golden design rules is set up for black plastic. But it's good. It's okay to have it. And like I said, it offers an opportunity for recycled content. So the idea with golden design rule number 2 is you're going to focus on 1, 2, 4, and 5. No number 3 plastic, no number 6 plastic, and no number 7 plastic. So this example here, that's a PVC container, and the container on the right, Tim Hortons, 2 years ago, they moved from a polystyrene lid on their coffee cups to a polypropylene lid. So they went from a number 6 to a number 5, because number 6 plastics weren't really getting recycled, and number 5 plastics are. And so that's a good move. That's in keeping with the golden design rules. The PVC is still commonly used, though. You see it a lot of automotive goods, hazardous chemicals. You actually see it a lot in little blister packs for your housewares. If you go into a store, you'll see that for your nuts and bolts and things like that. So there's quite a bit of it out there. The idea is to avoid using PVC because of the opportunity that it might get mixed in with the PET. Not all recycling facilities are using optical sorting. The older, smaller, little local recycling facilities are still doing a lot of manual sorting, so they can have a problem at that point. Avoid the PETG and number 7 plastics. So you see a lot of PETG and number 7s in things like cosmetics. So just move away from those. And this was another PAC award winner. They actually moved to a paper-based package. So there are opportunities to move out of hard to manage plastics and into something that is more compatible with recycling systems. So the golden design rules call them problematic. I just call them hard to manage plastic. If you limit the number of options, what you're doing is making recycling facilities less complex, which is good because recycling facilities are very expensive nowadays. You look at a large scale facility today, you're looking at $40–50 million for one recycling facility. So if you can keep it simpler in terms of the number of plastics it needs to manage, you're not putting in a lot of extra equipment in order to manage all of the plastics to get them separated out. So focus on PET, HDPE, LDPE, and polypropylene. You'll create economies of scale for capture. It means the equipment can focus on those plastics. You can put in the right equipment to capture just those materials separated, which means you're high grading it for shipment to end market. You'll get better market prices if you're not shipping blended bales. So it all works towards getting higher yields, higher value out of your plastic streams. Now, bio-based plastics are okay in the 4 numbers, 1, 2, 4, and 5. Bio-based does not mean biodegradable. Bio-based means that part of the plastic, so for example, the polyethylene and the PET, is coming from a renewable resource. So for example, corn. They're just making the ethane, which is made into the ethylene, which made into polyethylene. Instead of making it from fossil fuels, they're making it from corn or other biological sources, and they can substitute it. It is exactly the same in terms of its chemical composition. It is just as recyclable, and it can be captured. No problem seeing it, no problem capturing it, no problem recycling it. In the recycled PET, which is typically called rPET, for example, rPET is fully compatible with PET and fully compatible with bio-based PET, not a problem whatsoever. Now, the one thing you do want to stay away from, though, is degradable PET or anything like that. There's not much of it. I think it's all gone. It used to be around, but don't use anything that says it's biodegradable, oxidogradable, or anything like that in the plastics. They cause contamination problems for the recyclable materials. Now, number 7, PLA, which is polylactic acid, is not discussed specifically. PLA is considered a compostable plastic. Technically, PLA can also be very recyclable. I know a place that is recycling PLA plastic, but PLA plastic and number 7s aren't discussed. There will be future golden design rules, we believe, that will look at compostable plastics. A lot more work needs to be done on understanding what the composting systems of the world look like before you can set rules around what the plastic that would go into these facilities looks like. So golden design rule number 3, eliminating your headspace in your packaging. So this affects all pouch-based products, also things like chocolate bars, candy bars, anything that has space when you put the product into it. It's also, but it doesn't just apply to food. It also applies to cleaning products, dry groceries. They mentioned frozen foods. So if, when you go and buy, say, your chicken wings and it's in a bag, it shouldn't go to such the point that the bag is more than 30, the empty part of the bag is more than 30% of the total package of chicken wings, for example, you buy, even though it's in a box. So it's a waste of packaging. But more importantly, when you look at it from the Competition Bureau, the idea is that what you're doing is you're misleading the public. So there's a couple of reasons to do it. Canada does have a strict set of rules around headspace in their packaging. But the idea is to reduce the amount of packaging you're using by reducing the headspace. So you're going to right size the package, but you're also going to possibly have to change the packaging. Let me show you. So in Canada, the Consumer Packaging and Labeling Act says that you must put a package in the marketplace. If you look at the last line of the first bullet, displayed in such a manner that a consumer might reasonably be misled to the quantity of the product. So you can't do that, right? The idea is that, you open up your bag of chips. If you're buying a bag of chips and it's this big, everybody loves to pick on chips. But the bag is this big, and then you open up the bag and you go, but there's only this much stuff in it. Well, hold on a second. What in the world's going on? So the expectation is the bag was going to be full. So there are companies that have actually redesigned the bag. There are other companies that have redesigned their pouches for inside boxes even. There's an example of a cereal company. What they did was, when you think about when you're filling something, if it's a tall, thin package like this, then you can imagine when you're putting the product in, like say cereal, it goes in, but it doesn't have places to go, right? It doesn't have a nice angle of repose on the material. It has to go straight up. So it leaves a lot of dead airspace. And then as such, when it goes through transportation, it shakes and it starts to go down. So what one company did was they changed their package from tall and thin to shorter, more stout, and a little deeper, a little wider, right? So more square, so to speak. And as such, when the cereal went in, what it did was it settled more in the bag better, and then they can make the box smaller. So not only did they save plastic, they also saved boxboard for around it. So there's lots that can be done on that, right? So you might have to look at redesigning your packaging. You might look at redesigning your fill lines. It does apply to all pouch packaging types. So the way it's measured, it's fairly straightforward. You just take a look at the total height of your airspace in your package. So you look at the diagram on the left. And then if it's, say, a 30 centimeter tall package, the fill height has to be a minimum of 21 centimeters, 70%. So you can only have 9 centimeters of dead airspace in the package. The same thing applies with flow wrap in horizontal filling. So the chocolate bar there, make sure that the space in the chocolate bar does not exceed it. I was presenting this yesterday and somebody was mentioning about some cereal bars in the marketplace. I don't know who, they didn't offer the name. It doesn't really make any difference, but they were mentioning about the fact that yes, the bar inside the wrapper is now so small that there's a lot of dead airspace. That would be an example of a company that is going to have to look at this and say, okay, now what are we going to do? Because yes, you still have to get your name on there. You still have to get all the nutritional information on everything. So it'll be a matter of how to redesign things in order to ensure you still get all the information you need to get to the consumer, but also reduce the amount of plastic packaging you're using. So on the right is an example of a redesigned plastic package. It was a winner of our Award of Distinction, the Global Leadership Awards in 2020 from PAC. And the Tide, it's a bladder in a box. So, think about your wine in a box. It's the same idea. It's great for e-commerce, but there's no dead airspace in this now. So because they fill the bladder, they put it in the box protects the bladder. You don't have to worry about, damage or anything. You get full 100% dispensing of the product, and you reduce your plastic use tremendously. So that's just an example of one. So goal design rule number 4 is to reduce plastic overwraps, only use them when necessary. So you think about it, typically, first thing you think about with plastic overwraps is in, say, for example, a 24 pack of water or soft drinks. You get the material, it's 6 by 4, and then there's it's sitting in a corrugated tray, and then there's plastic overwrap around the whole thing. Well, that is, there's a lot of plastic used in that, plus it's got the tray. So if you could reconfigure it, then you could save plastic, and you could actually also save the tray. I'll show you that in a second. But the other thing is, it doesn't just relate to just things like purchasing 24 packs of a product, but also just buying multiples together. A lot of the time, multiples, when you go into some stores, instead of buying one, you'll buy 4, and they wrap the 4 of single units with a piece of plastic around them, or they'll wrap 2 with a piece of plastic, and sometimes they'll wrap 2 with a piece of plastic and it's got another full label on it. And depending on what the plastic is, it could be problematic if they're using, for example, a PVC shrink sleeve around something. So again, it speaks to not only this golden design rule, but also golden design rule number 1, and also golden design rule number 8. So there's a lot going on what you can do with your packaging. So take a look at it. Where there's bulk packaging, what can you do to reduce it? But respecting, of course, you must maintain your health and safety on your packaging when it's delivered if it's removed. So for example, you couldn't put a single label around 2 units and have a nondescript unit inside, because as soon as you remove the outside label, there's no information on the container to be consumed. So you couldn't put 2, say, juice boxes inside something with nothing on them, just make them white paper product or a white plastic bottle or whatever, juice containers, and then wrap it in plastic and put all the nutritional information on that, because then that inside container doesn't have anything on it. So it can be a problem. So you got to make sure you maintain all those rules. So here's an example of changing geometry. So instead of going with this package on the left, what you do now is you reconfigure it, you do zigzag, you shrink it down, and you use less plastic. You're also getting rid of the corrugated container. So you're doing reduction as well, not only of the plastic, but also using corrugate. So that's one option. The other option is to look at different ways of joining multiple units together. So this example on the upper right-hand corner with the X through it, We purposely don't show brands with problems because I don't want to be pointing things out that are necessarily not great. But this is a twin pack of a product, and then they wrapped it in the shrink label. So the shrink label may be a problem, but it's also excess plastic packaging relative to the unit count. So instead of using plastic, they could have gone with something else instead of that shrink label. For example, they could use, if it's like a juice, for example, vegetable juice or something, you can use the bottom in the middle here. You can use just a little carry handle cap between the two of them. It snaps over the top, and you can now carry 2 units. The bottles stay as they were, but you're not using any excess material. That plastic retainer that's between the 2 caps can be recycled. Alternatively, you can use paper-based. So this Coke example here, there's a multiple units of Coke. They're using a box board snap-on sleeve, so it pushes down, it links or catches underneath the lid of the aluminum can, and you can pick it up that way. Or you could do the one on the left here, this with the 6-pack, and they even come with little punch-out marks where you can actually carry then the 6-pack with and there's no use of plastic whatsoever. Another alternative is the bottom left-hand side here. This was a product that was invented in Canada. It's made out of HDP plastic. It's 100% recyclable. You can go pick out, say you're going to your favorite beverage establishment and you're buying a multiple number of units. You can put the cap on top of it, and then you can carry the multiple units out with this cap. And then when you're done with it, you can either reuse it if you want, because it is reusable, or what you can do is put it into your blue box. It's HDP plastic, and it will be recycled. And finally, we have the container lid, or sorry, the multiple unit cap that Budweiser came out with. It was an award winner in 2021 on our Global Leadership Awards. Again, no more plastic, just a cap on it. And it's made out of corrugated material, 100% recyclable, as are the cans, of course, 100% recyclable paper product, no plastic, you can carry it. And it's a great opportunity to reduce the amount of plastic overwrap you're using on your containers. Golden Design Rule number 5 is the equivalent to Golden Design Rule number 1, but on PET thermoform packaging. So thermoforms, it's like I said, the spinach you might buy your salad that you get in the produce aisles, that's where you commonly see PET thermoform packaging. Initially, when the Golden Design Rule was developed, the Golden Design Rules were developed by an international panel through the Consumer Goods Forum. It was led, co-chaired by Unilever and Loblaw. But there's no but there, sorry. The Golden Design Rules were developed for an international audience. So they weren't developed for just the Canadian or American or European marketplace, but rather they tried to develop the Golden Design Rules for everybody. Now, Golden Design Rule number 5, when I first saw it, I was part of the panel that was developing these Golden Design Rules. When it was developed, what they had in here was, oh, you can use color and it can be opaque and don't worry about it, we'll recycle it. And because they weren't aware of the technology developments that occurred right here in Canada that could now take thermoforms and actually put them back in the bottle, because PET thermoform grade and PET bottle grade are not equivalent. You can't take PET thermoforms and make PET bottles out of them. There's a problem with it. It's called the intrinsic viscosity. It's too low. It needs to be raised before you could turn it back into PET bottles. And there's a company right here in Canada, in fact, it's in Ontario, called Ice River Springs, who can take PET thermoforms. They've developed proprietary technology. There are other companies now that do it as well, but they developed it. And they can take PET thermoforms and they can, through a nitrogen process, they can raise the intrinsic viscosity and make it back up to the equivalent of PET bottle grade and make PET bottles from it. So if you see Ice River Springs, it's you see Ice River Green. They do a lot of bottled water for a lot of different companies. But they take it from the thermoform as well as the bottles. So when I was working with the Golden Design Rule team, they weren't aware that the technology was out there that could actually take thermoform and put it back into bottle, because like I said, PET thermoforms are very difficult to manage on their own. They don't get separated from bottles. And so things tend to get downcycled rather than upcycled. So this is an example where a Canadian technology has now made the world aware that there's an ability to upcycle PET thermoforms to bottles. And as such, they changed the golden design rule, number 5, to recognize the role Canada has taken in leading the development of a better technology for PET management. So as such, whereas the first version of golden design rule number 5 said, yeah, it can be opaque, it could be colored, doesn't make any difference. Just do your best to recycle it. Now, the golden design rule is almost exactly identical to golden design rule number 1, in that you are to keep it with no color, so no opaque PET, no colored PET, so no colors in your PET thermoforms. And there's a lot of colored PET thermoforms in the marketplace. You see them in the produce aisle as well for things like mushrooms, for example. There's a lot of colors in the things. You also see PET trays for takeout materials. Like if you go to a quick service restaurant, you'll often see a PET tray. So there's lots of opaque PET thermoform trays in the marketplace. The idea is to move back to clear PET trays, and so that there's the best opportunity to recycle them. Again, they can be light green or light blue, just like the bottles, but make sure that they're clear, not opaque. So again, if they are opaque, they are not recycled in anything other than more opaque PET. So you take out all the colored PET resin thermoforms. If you had enough of them, again, it comes down to economies of scale, because when these end markets batch run these things, they don't need a ton. They need hundreds of tons of material made available to them to run it all at once to make their next resin. So having a little bit of something just becomes a contaminant in the main product rather than something that's available to them to be made into something else. So if there's only if there's opaque PET thermoforms, they pull those out. They can be made into more opaque PET thermoforms, because they're not going to make them into, they're not going to high grade them into bottle grade PET because we're not supposed to be making colored PET opaque bottles. So again, downcycling, but nothing better than that. So remove the PET colors, keep it clear. Now, CPET, crystallized PET, polyethylene terephthalate, is compatible and acceptable. It is typically, you'll see it, it's white. You'll see a white thermoform. Now, the white does not come from putting colorant into the PET, rather it comes from the extra heat cycle that the PET thermoform goes through when they're making the thermoform package. So when they put it through the secondary heat cycle, what it does is it turns it to a white. Now, when it goes into the program, it gets captured, goes through mechanical recycling and gets melted again, the color will come out of it. Now, the difficult part, of course, is understanding when it goes through the recycling process, whether it's a white PET, opaque PET thermoform, or whether it's a white thermoform that's CPET and can be captured for recycling. So they're working on it, but right now the color can be removed on processing and it is an acceptable plastic. So thermoforms must be clear. The one on the middle with the X through it, you see those all over the place. Quick service restaurants use them everywhere. The black tray, typically you'll have a clear lid so you can see the product inside. And the idea is to get rid of the black tray altogether, move to a completely clear tray. Now, the one on the right is not compatible with the one on the left because the one on the right is for fruit. You notice it's got the slots in it, but there are a lot of clear PET clamshells available in the marketplace where both the top and the bottom are clear. So move to a completely clear tray. Don't use any colorant, don't use opaque, so that, remember I mentioned the mushroom punnet blue there. Don't use the blue PET thermoform. And again, but CPET is acceptable, so it would be light, it'd be white. But now on the bottom right-hand side, another one of our winners we've got is a clear PET tray. It was an award winner of distinction from Global Pack Leadership Awards. So opportunity there. If you move to those, then you've got PET that's compatible with best opportunity for upcycling or keeping it as clear and keeping it, again, keep it in the circular economy, increase yields at end markets, increase opportunity, increase the amount of material available for recycled content. So I'm going to take a break here, Andrew. That's the end of goal design rule number 5. And we're in good shape. Let's take 5-10 minutes for questions.
Yeah, perfect. So Dan, here we go. Question 1, the source of our data for the recycling rate information. So it was in our introduction.
Mm-hmm.
Yeah, what's the source of that data?
If you go to the extended producer responsibility stewardship sites, so you go on to Trees Quebec, Stewardship Ontario, Multi-Material Stewardship Manitoba, they post their annual reports, which shows their recycling rates for their materials. It's available online.
There you go, perfect. Next one. So this relates to, it was a question that came up during the discussion of Golden Design Rule number 5. So is PET flexible film recyclable with the PET bottles or the thermoforms?
The difficulty with PET flexible film is it has to be attached to a PET container for it to be captured as PET. Otherwise, typically the flexible film will end up in with the polyethylene film, and PET is not wanted in with the polyethylene film at all. So I did look at it. I did a study during this past calendar year, looking at how many of the PET thermoforms, they've got the lidding material on them, how many people leave the lidding material on and how many people take the lidding material off. And so I took a large sample off of the sort line in the recycling facility I was working in, and I found almost exactly half the people left the lidding material on and half the people took the lidding material off. So if the lidding material is on the PET and it's PET, it will be captured and can be recycled. If the lidding material is off, it'll end up floating everywhere in the recycling facility, often end up in residue and it won't be captured. Or almost worse, it would end up going with the polyethylene film, where it would have to be taken out. They would, when they wash the PE film, they would have to put it through a sink float, and they would sink out the PET films, where they would not be captured for recycling. They would probably go to an alternative fuel or something else, because there would be other films that are in there and caps and everything else. So not the bottle cap, but rather the sleeve on the cap.
Okay, very good. We'll shift back to Golden Design Rule number 2. And just a brief comment, I guess a recap on what is discoverable black plastic. Sort of how does that work?
Well, what they do to make it discoverable is they put a dye into the black plastic that when it goes under an optical sorter with the near infrared light, it actually shows up. The spectrum of light it shows is not black but blue, so that they can see it. I'll point to an example. If you look into Unilever and their black plastic, they have a discoverable black plastic, and so you can type that into Google and you'll find it. And I believe it's on their Axe body products where they're using it. So that would be an example. Don't go beyond the Axe part, but I do know that Unilever does have a discoverable black plastic in the marketplace.
Got it. Thank you. Still with number 2, a couple of questions related to, well, PHA, PLA. So one question just simply, is PHA okay? You were referencing PLA. So is PHA okay? And I'll tack on a second question, Dan. Is cardboard lined with PLA okay?
Okay. Well, the PHA falls into the same category as PLA. There are no golden design rules around compostable plastics at this point in time. I do believe they will be coming out with something. I don't know when, but right now PHA would fall as a number 7 plastic, and the golden design rules are saying avoid number 7 plastics at this point in time. Now, the other part of the question with PLA liner on a corrugated container, if the PLA liner will separate completely from the corrugated container and not impede the screening process in a paper mill, then it shouldn't be an issue. Of course, the corrugated container, if you're thinking PLA because it's compostable, well, nothing gets composted at the paper mill side, it gets pulped. And so the PLA, whether it's PLA or polyethylene or otherwise, it doesn't make that much of a difference unless it is a PLA and the film is so fine that it actually breaks down in the pulping process. So that would be different again.
Yeah, good. With regards to PVC, just why isn't it recycled? What's the issue there?
Well, technically, this is why I don't like when they call them problematic materials, because technically all of the plastics that are in the marketplace are recyclable. End markets could recycle everything. The difficulty is getting enough of anything. There's so little PVC left in the marketplace in rigids that to spend the time and money, like you're thinking an optical sorting unit, just so people know, for a single resin in a mid-sized plant is going to cost the recycling plant around $250,000 to $300,000. So if you're spending that much money, you want to get your biggest return on investment, which means focusing on the number 1, 2, 4, and 5, particularly for rigids 1, 2, and 5 plastics. And as such, spending that extra money to capture number 3 plastic, which there's so little thereof, to send it to a market, people do recycle PVC. Think of your linoleum flooring. There's lots of PVC recycling, but it's more on the industrial side than it is on the residential packaging side. There just isn't enough of it to warrant making the investment into PVC or polystyrene nowadays. Polystyrene's death knell came when the move was made from polystyrene clamshells to PET clamshells. And so that really removed a lot of polystyrene from the market, again, then making the economies of scale for warranting capturing polystyrene and PVC. It got to the point it just doesn't make sense anymore.
Got it. Okay. Dan, I just want to address a question that's come up a number of times. It's more administrative, and that is people are asking, will the presentation be sent out following today? And the answer is yes. So it will be sent out to registrants. So a couple more, Dan, I'm just looking at the time. We got about 3 minutes to the hour. So we'll do a few more and then get back to Golden Design Rule number 6.
Okay.
So here's one. Is mineral filled polypropylene, MFPP, considered recyclable?
Okay, depends on what the mineral is and how much of it.
Yeah.
Now, generally, there's a Golden Design Rule coming up where it's indicating it's for plastic films that the non-plastic film element can't be more than 10%. The same thing applies to rigid bottles. It's not specifically laid out in a Golden Design Rule, but the idea is that any filler elements you have in your bottles should not exceed 10% of the weight of the bottle. So that PET punnet that you see on the screen right now, for example, there's often found in polypropylene as well, will have calcium carbonate into it. I actually speak to it in later Golden Design Rule. The idea is that don't have excess filler in it because for a number of reasons. First of all, you can't make polypropylene out of calcium carbonate. Second of all, if there's too much of the filler into the polypropylene such that it changes its specific gravity to greater than 1, it won't float out in the wash cycle in the sink float process, and you'll lose it. So the yield goes down. In fact, I was talking to someone that's in the polypropylene end market, and he was saying to me that the yield on polypropylene is dropped by about 45% because of the mineral filling that's being done with polypropylene packaging, is that they can't capture the polypropylene in the recycling process because of it's changed the specific gravity. So it's ending up falling with other non-polypropylene products, and it makes it very, very difficult to capture. So.
Got it. Time check. Okay, Dan, I'd say let's, we've got some other questions, but I'll keep looking them over, but why don't we get back to our program, and then again, toward the end of our time, we'll get back to some of these questions.
Okay, sounds good. Okay, Golden Design Rule number 6 applies to flexible plastic packaging. So that's all your pouches, but it also applies to all of your films as well. So any plastic packaging that's in a film structure or a what I call a semi-rigid structure, a stand-up pouch, for example, needs to focus on being preferably more than 90% mono polyethylene or 90% mono polypropylene by design in the Golden Design Rule. Now, in Canada, what we want to see is a focus on polyethylene because our end markets that we've got, which are very strong for film, are not polypropylene and polyethylene don't talk to one another really in the recycling process. You can have a little bit in either, but even though they're both polyolefins, they're not the same plastic. Our end markets are heavily focused in polyethylene because that's what we primarily have in Canada. So you're asking the question, then why does it say polypropylene or polyethylene? Again, these Golden Design Rules were developed for an international audience. Polypropylene is much more heavily used in Europe than it is in North America. And so they put both in because I actually questioned it. I said, okay, why? We don't really want polypropylene films. And just so you know, a polypropylene film, you often see it in the new replacement to the takeout single-use polyethylene film plastic bag in grocery stores, for example. The new ones that they almost feel like they're textile, stamped. They're used by a number of companies. Those are polypropylene. Or of course, you see woven polypropylene bags, which is a common, that was a first generation reusable bag that grocery stores and other retailers were selling. So that's polypropylene. The polyethylene is the single use grocery bag, for example. If it crinkles, it's HDPE. If it doesn't crinkle and it's nice and soft feeling, that's low density polyethylene. That's how you tell them apart. They're both in use, but in Canada, we prefer to see the polyethylene only. So the idea is, though, to keep the density less than 1 gram per cubic centimeter. That way, when it goes into the wash cycle, it floats up. So the question about PET film, for example, it's got a specific gravity, a density greater than 1. It will sink out. Any barrier layers that are in the plastic films, regardless of whether it's just a plastic film or a plastic pouch, should not exceed 5%. It says here that the minimum of either 80% mono polyethylene or mono polypropylene is required, or 80% mixed polyolefins. Again, mixing polyolefins is not preferable. It isn't really usable here. But 80%, talking to the end markets through our discussions with the Canada Plastics Pact and just my general discussions with the end markets, no, 80% is way too low. That's way too much material that they have to compensate for in the recycling process. They want to see 90% minimum mono, so one resin, polyethylene, or preferably 95%. So it's really pure polyethylene. And if the reason they do that is that they want pure polyethylene to make pure recycled content polyethylene, which has higher and better and more end uses. So of course, the more things they have to manage with different barrier layers and fillers, et cetera, that are in the films and the pouches, the more things they've got to manage at the end market. And then when they're putting it through the recycling process, they have to manage that again. If there's too much of something, then they have to dilute it out, or they just simply can't use that product. So just like with what you saw with Golden Design Rule number 1 and 5, no PVC, no PVDC, no fiber, aluminum foil, PET, for example. So with Golden Design Rule number 6, the most common plastic pouch in the market is PET on the outer side and PE or polypropylene on the inside. Then now there may be a barrier layer of EVOH or aluminum or something else in there, but that's the most common plastic structure is PET outer and PE inner. And the idea is now it's to find alternatives to eliminate the use of the PET outer. So you're looking at a monostructure, so polyethylene, barrier layer, polyethylene, or by Golden Design Rule design, polypropylene, barrier layer, polypropylene, where that barrier layer is no more than 10% of the packaging weight. And it also use only barrier layers and coatings that are proven not to limit recyclability. I encourage you to go look at the APR design guidelines for plastic film manufacturing. It's a great resource. I'll actually give you the link in a few slides so you can take a look at it. So it's aluminum oxide, silicon dioxide, EVOH or PVOH are the ones that are recommended. So avoid mixing the resins, choose monostructures, focus on PE, avoid all other films. And again, the idea with the circular economy and the golden design rules is the more we have of one thing, the better the opportunity we have to maximize yields, maximize opportunity for recycled content, and keep the material in the circular economy more and more. Consistency in film use. So the pouch on the left is a typical multi-material, multi-laminated plastic pouch. You see it a lot for snack foods and animal food products, pet food, snacks and treats and things like that. It's used elsewhere as well, but like it's used in the laundry aisle for the pods. It's all over the grocery store, and it's growing very quickly. So the thing is to move away from those structures to monostructures. Here's another one of our award winners we have from Award of Distinction from the 2021 PAC Canadian Awards. That's a mono-based structure, so it's polyethylene based. Barrier layer built into it, but it's only polyethylene, so it is a technically recyclable plastic package now. Now, unfortunately, it's not considered recyclable because the Competition Bureau sees pouches as a separate format, and pouches are not accepted by more than 50% of the marketplace, so therefore you can't call it recyclable, but you can. It is definitely technically recyclable, which is the first big step. The more we get to technically recyclable, then we can move them to recyclable, which moves them to recycled. And another example, you often see coffee bags that have got multiple material layers. There's an example of a coffee bag that is a single material. So again, focus on avoiding incompatible barrier layers, focus on minimum 80, but preferably 90. And in fact, end markets really would love to see 95% polyethylene, but 90 is acceptable to them with a 10% barrier layer in there is fine. So alternative minimum of polypropylene. If polypropylene does continue to grow, then what's going to end up happening is that we're going to have recovery programs for polyethylene separated from polypropylene. And it will happen eventually as polypropylene continues to grow in abundance in the marketplace. The golden design rule number 7 is everything that they said about PET, with the exception of is now being applied to HDP and polypropylene. The exception is, of course, HDP and polypropylene don't have to be clear. They can be colored. You can use any color you want for it. They are opaque by nature. I know that HDP natural is, you can somewhat see through it. It's commonly used for milk, for example. Polypropylene natural, you can see through it somewhat. You often see those in tubs when you go to a deli, for example. There's all sorts of applications for both. Those are worth more if you can keep them separate in the recycling system, and recycling programs, particularly out west, will capture the HDP natural separately from the HDP colored. But otherwise, the idea behind golden design rule number 7 is to increase the recycling value for all rigid HDP and polypropylene. We're not talking about films now, just the rigid containers. Again, remember we had in golden design rule number 1 was ensure the labels, the inks are not, and the caps, lids, whatever are, and the adhesives are not problematic for recycling. So ensure that the adhesive breaks down in water, or so in other words, water soluble or light caustic soluble. The inks do not stay in suspension such that when they put, they flake the plastic, the ink sticks to the flake, and then it causes problems where you're not getting a nice, clean HDP recycled pellet. Make sure that the labels that are on the packaging are not problematic so that you can't recycle the material. Now, the good news is if you, for example, if somebody was to put a PVC shrink sleeve around the cap of an HDP bottle, when it was shredded, the PVC would sink out, the HDP will float out, as with the polypropylene, and it would not be going through the recycling process. However, they are suggesting phasing out of paper labels and PET, PETG, PLA, and PVC because of the concern, but it's more related, as much as it is, they like to get rid of all of the labels and sleeves. It's a concern that if the adhesive doesn't release, then you've got the PET, PETG, et cetera, still stuck to the bottles. And then, of course, it impedes the ability to make a good, high quality recycled content pellet, right? Now, at the end markets, even though we send all colors of HDP and polypropylene to end markets will color separate. So again, that's where they want to make sure that you don't have the ink, because they will separate white and blue, for example, HDP out of yellow and orange, and make an orange pellet and a light blue pellet or a white pellet if they separate out the white HDP, for example. So anything that's a contaminant that sticks to the bottle that can possibly impede the ability to recycle it is trying to be discouraged here through Golden Design Rule number 7. Moderate direct printing, you can use in-mold labeling, but make sure the in-mold label is the same resin type as the bottle itself. So compatibility is really key. The other thing really key in this is that question that came up at the break there is don't use fillers that increase the density of the package to greater than 1 gram per cubic centimeter. So the idea of using mineral filled polypropylene, limit it to 10% and make sure that the specific gravity or the density does not increase to greater than 1 gram per cubic centimeter. Again, the whole thing, all these Golden Design rules is maximizing the value of the package, maximizing the yield, so reducing yield loss, which can be extreme in end markets. You know, they can have yield losses of 25, 30, 35%. That's nothing but drives up the cost of the recycled plastic. All those plastics that aren't recycled end up going to disposal. It's best that if we keep the plastic together with the plastic we want and keep the common elements together, so the labels and the caps and the sleeves, et cetera, all compatible materials, either by having them separable so they can go to one or the other, or compatible with it so it stays with the product, the package. Then we're going to increase yields. It's going to drive down costs, keeps everything in the circular economy, has greater opportunity for recycled content. So lots going on, but that's the whole purpose of all of this. And PET is the most common plastic, HDP is the second most common plastic. So there's a lot going on. It's used in a lot of different product lines. So again, make sure you do everything you can to eliminate problems. I encourage you again to look at the Association of Plastics Recyclers APR design guide, and there's the website for it. It's got everything in there for rigid plastics, flexible plastics, et cetera. The testing protocols you can go into ensure that if you're doing flexibles, that you get your, and you're putting barrier layers in to ensure it's considered recyclable. There's a whole design guide and testing protocol on what to do to have your product tested to ensure that it can be considered recyclable. So application for consumer product goods manufacturers, squeeze tubes. Squeeze tubes are commonly, there's a lot of different combinations out there, aluminum, some metals in there, they got different plastics and all together. You think about when you go to the housewares aisle of your favorite store and you see the tubes and the bend. Now, even for us older folks, you remember your toothpaste tubes used to have aluminum in them. You bent them, they would actually stay bent and things like that. The new toothpaste tubes, there's another award winner, award of distinction for the Global Leadership Awards to Colgate. That is a 100% recyclable HDP tube. There are actually quite a lot of HDP tubes out in the marketplace. I know that in the recycling system, we see the tubes coming down the line. The optical sorter does capture them. And so they can be recycled and they're in more common use than people believe. You can put a barrier layer in them, but again, keep it to less than 10%. However, the opportunity is there to move to a recyclable plastic package to meet the needs of your consumer, but also keep it such that it's recyclable and it can be recycled at the end market, increasing yields, increasing opportunity for recycled content. I mentioned in-mold labeling, ensure it's the same material. So a PE label with an HDP bottle, very commonly used nowadays. You see it in detergents, for example, ice cream, lots of other examples of in-mold labeling. Now, avoid full body labels. I mentioned that with the PET. The same thing applies with HDPE. There are a number of applications, and there's some in dairy, for example, where they have an HDPE bottle, but they put a full body label on it that's not HDPE or polyethylene. And so, again, if the bottle has got a label on it that goes from the very bottom to the very top, and say it's a PET label on an HDPE bottle, it goes through the optical sorter system in a recycling facility, it's going to be ejected as being a PET bottle. Well, hold on, we don't want HDP in the PET stream. It's a contaminant to the PET people. We want the HDP to go with HDPE. So putting a PET label on an HDP bottle sends it to the wrong location. We want it to go in the right place maximize yields. So make sure that your sleeves are not full body. I use this as an example. This is for an aluminum can, but it just equally applies to a bottle. The full sleeve changes what is seen by the machine, can't find it as being the right material, and it goes the wrong place. And again, it's lost to the system. We're not getting maximizing yields on plastics recovery. The full body label, the full body label, there's don't use that. Rather use something like this small full wrap label, whether it's plastic or paper. That size paper label would not be as much of an issue, again, as long as it completely separates from the bottle and there's no residual paper left and there's no adhesive left. Avoid adhesives which are not water soluble or slightly caustic soluble. Here's an example. This is on a glass bottle, but again, the application is you want the label to fully separate from the bottle and disappear. So you don't want clumps of paper. That's why they don't like paper labels on bottles and large paper labels, because then you get a lot of paper in suspension. You know how sticky is, remember your paper mache, you think of that, right? You take the paper and you break it down in little pieces and then it sticks to everything. They don't want it stuck to anything. So you want to have it separable and removable and it disappears completely. And also, so a small quantity is better. Fillers, we talked about calcium carbonate during the question period there. It renders it non-recyclable. You can't make polypropylene out of calcium carbonate. And I mentioned about the yield loss. Some of these calcium carbonate additives in polypropylene and PET and that are now upwards of 40%. Well, 40%, it's almost 50%. It's half stone and half plastic. You're trying to make a plastic container. You can't, the amount of dilution that has to happen in order to get that calcium carbonate down to a minimal level in the recycled plastic. All you're doing is degrading the recycled plastic element. If we want to use recycled plastic in more and more applications, then it's got to be pure. One of the biggest criticisms of recycled plastic is it's not as good as virgin plastic in terms of its purity. So its applications aren't there. It causes problems on run lines and fill lines and extrusion lines, et cetera, and molding, in mold, all those things. Anytime there's additives put into the plastic, that just increases the opportunity you're not going to be able to make a great pellet at the back end. So reduce the amount of fillers used, and also just to even be able to capture it, you can't have so much filler in it that it lost the system. Like I mentioned, that company I was talking to that says they've lost 45% of their polypropylene because of fillers in the polypropylene. Caps and closures, avoid incompatible caps closures, avoid PVC. There's a new liner cap that came out for squeeze bottles that is compatible. So there's innovations happening all the time. The PAC has their design leadership awards, and when I was doing this about 5 years ago, there was 5 applications for awards in sustainability. When I did my judging this past weekend, there were 22. Their applications are happening and improvements are happening every single day. There's lots of opportunities out there to make your packaging better.
Dan,
yep.
We're at 10:17.
Okay, I'll go a little quicker. It should be a little faster now. Thanks, Andrew. Golden design rule number 8 is reducing the use of virgin plastic in business to business. This is the only business to business one. This is not consumer facing. This is business to business facing. So it's eliminate use of plastic wherever possible. And where you are using plastic is look to recycled content. So common example is from your distribution center, use, for example, the pallets on the left are CHEP pallets, are reusable and recyclable. It's a return system, deposited, etc. That's the best option. If you're going to use plastic in your pallets, make sure it's recycled content. Now, the one on the right, you might never be able to see because it's not huge on your computer screen, but those are all different, slightly different colors of blue. That's because those are all 100% recycled content, HDP, refillable plastic totes and reusable plastic totes. So again, you notice that those are blue HDP. So that tells you if they're recycled content, they had to be made from blue HDP to begin with. That shows you that the end market can do an awful lot more than we give them credit at times. But they're recycled content HDP refillable containers. Make sure you're using recycled content wherever best. Golden design rule number 9 is recycling and reuse instructions on consumer packaging. So generally speaking, that's the how to recycle label. Now, for Canada, for those of you in the audience that are from Canada, we really don't have a lot of need for the package label because in Canada, all rigid plastics are considered recyclable, all of them. We only need, even though the jurisdiction or responsibility for waste falls to the provinces, when I did a study, I looked at the top 10 size cities of every province in Canada. Every single one of them collected all plastic rigids, with the exception, some don't want black plastic, for example. But that's a resin within a resin. But for generally speaking, all rigids are acceptable for recycling across Canada, which renders the label redundant in the United States. Recycling programs aren't as common or inclusive as the Canadian ones are. So therefore, the how to recycle label has a lot more application. This is actually taken from a US example because it says at least 60% of Americans can recycle the package. In Canada, the requirement by the Competition Bureau is 50%. Now, the other thing to bear in mind is that when it comes to flexibles, that's a little different. Flexible stand-up pouches are not considered recyclable. You might want to look at starting to put labels on only to show it. The other thing to bear in mind, show it's technically recyclable, but you don't want to get yourselves in trouble by saying something's technically recyclable if it's not considered recyclable. So even though you might put a label on that says it is acceptable, be careful on that one. I just caution you on that. The other thing, when you think about it in Canada, think about how big we are geographically, but how small we are population basis. To say to your consumer, check locally, when we are so spread out and we're so tiny in terms of population, you can imagine telling people to go look out everywhere to find out whether your plastic package is recyclable. It's just easier in Canada, it is. So in the US, not so much. So the application of the label makes more sense. Again, the Golden Design Rule number 9 being a full world application. They put in Golden Design Rules to apply to a broad audience. Doesn't mean that everybody has to adopt all the Golden Design Rules. Well, by the way, they are voluntary and you don't have to, it's not an all or nothing. You don't say, okay, you have to accept and do all 9 Golden Design Rules or none of them. It's you pick and choose which Golden Design Rules make sense for your company. So just very quickly, that's the end of the Golden Design Rules. So I'm going to very quickly, I got 3 slides on what PAC is doing to help. We've got the Packaging Innovation Pathway. It's a PIP 360 package. That's what PIP is, the Packaging Innovation Pathway. 360 degrees in a circle. We developed a circular benchmarking tool, which examines material composition, including your recycled content and your level of renewable use material. It looks at the amount of reduction you've done and your recycling rate for your package. And we'll give you a score out of 360. But more importantly, we also provide pathways to circularity because there isn't a 360-degree package in the market. There is a 352. It's a 100% recycled content corrugated box gets a 352 score. So you can get very close. But the one thing with the recycling rate is until you get a recycling rate of all your packaging to 100%, you can't get to 360. But we can get very close to 360. The important thing with this is with all these Golden Design Rules and the Canada Plastics Pact is that we are looking at plastics consistent with the Golden Design Rules and Canada Plastics Pact. We can also report back to you on your Canada Plastics Pact reporting categories in terms of recycled content requirement of 30% by 2025 and your 50% recycling rate by 2025. So there's the list of all the plastics. When the first version that's in the market has 15, just shows you what the implications are of the Golden Design Rules on how you look at your plastic packaging. There are now, this has been vetted by the Canada Plastics Pact, there are now 36 plastic packaging categories to consider to address all of the Golden Design Rules that I just presented. So it isn't just as simple as a number 1, 2, 3, 4, 5, 6, or 7 anymore. And I think that's important for people to understand. The Mobius loop numbers, that's nice, but that's just a starting point. Really, we now have to look at breaking down each of the resins more discreetly with all the packaging elements that are within it to identify opportunities for recycling and improving packaging. So the Packet team is available to you to help you with scoring your packaging, help you understand your pathways, what you need to do to stay consistent with the Golden Design Rules or to help achieve the Canada Plastics Pact's goals of the 30% of recycled content and 50% for recycling rate on your packaging. So we invite you to contact us, and you'll get the deck. So you'll get everybody's email addresses. So finally, the Golden Design Rules are voluntary in Canada under the Canada Plastics Pact. We are the first plastics pact that's adopted formally the Golden Design Rules. It is part of the CPP. The targets on recycled content recyclability mean that by adopting the Golden Design Rules, there will be more interest and involvement by end markets. Remember, we're small. So if we can focus our attention on just a few plastics, which increases the amount we have in a smaller area, we're going to get more interest by end markets to make investments, to give us more recycling options, and also for the more complicated packages, more chemical recycling options, which is possibly or even probably where we're going to have to go unless everybody moves to monomaterial stand-up pouches in order to capture these stand-up pouches for recycling. We're going to see higher recycling rates for PET, HDPE, and polypropylene. Note this is all done outside of EPR programs. It's not an EPR-based initiative. This is the Golden Design Rules and the CPP are all separate of any EPR program. This is where we're going to see packaging design change through these programs. And we're then, by getting more into the system, we're going to have greater material quantities available for recycled content. And that's it. Wow.
Well done.
In an hour and a half.
Yeah, nice job, Dan. So audience, thank you for your attention. And we've got a couple of minutes so we can flag a couple of questions. And then as mentioned earlier, we will send out the recording of this session. So one of the last questions is, will the 36 types of plastic chart be made available? Well, it will be available in the recording. So Dan, again, we've got more questions than we can possibly handle in 3 minutes or less. So I've flagged a couple that I think have some broad applicability, including this one. So with regards to the number 9 rule, we've mentioned that pouches are not typically considered recyclable. So one question is, where would one find that statement, I guess, within the GDRs? And then the comment here is, we're moving to a stand-up pouch with 25% recycled content. Even that would not be considered recyclable?
If your stand-up pouch with 25% recycled content, I applaud you, by the way, for going to recycled content, is just polyethylene or just polypropylene, but really in Canada, just polyethylene, then technically, and again, it's technically you're recyclable. The difficulty is that the Competition Bureau, if you look it up, when it comes to, it used to be that they would say your package is recyclable if it fell within a specific resin. So PET, yes, PET, no. They've gone further than that now. The Competition Bureau now says not only what is the resin you're using, but what is the format of the resin you're using. So a stand-up plastic pouch is now separated out as being identified as not recyclable, even if it's just polyethylene based. Now, I encourage you to keep doing what you're doing in doing recycled content within your pouch, because you are showing your consumers that you're moving to you're helping close the loop. So even if your pouch is not considered recyclable yet, it will be eventually, and I don't think it'll be too long. British Columbia does actually collect all of the pouches through a depot network, not curbside, and they do recycle some of them through the process, proprietary process of their end market out there. So it is possible, but it's just new, it's just developing. And as more chemical technologies come on side for managing multi-resin materials, you're going to see more and more opportunities to increase recycling. So keep doing what you're doing.
Got it. All right. Dan, we're at 28 minutes past the hour. I think there's a lot of good questions here, but we'll do our best to sort of collate them and see how it makes sense to respond. But regardless, as mentioned, we will be sending out the recording of this session. So we hope you can take a moment now just to rate the session. We very much appreciate that. And again, on behalf of PAC Global, we appreciate you taking the time to join us today. We know it was a lot of information packed into 90 minutes, but we certainly hope you've learn something new, and at least it will raise some questions for you to consider going forward. And then potentially there have been some interesting solutions provided as well. So Dan, any last words from you for the group?
No, we'll do our best to get to the questions that you have posted, and make sure we'll figure out how to get the answers back to people. But I thank you very much for your time today. There's a lot going on there. You can look up the Golden Design Rules, take a look at the Canada Plastics Pact website, and then there are links to the Golden Design Rules through the Consumer Goods Forum. So if you want more information, you can go there. Thank you very much, everyone, for your time today.
Okay, everyone. Yeah, stay healthy, stay well, and we'll look forward to seeing you again.
Bye now.